Okay, so the topic for this video is going to be about the distance and midpoint formulas. Our goal here, our essential question that we're going to try to be able to answer by the end of this video is, how do I find the distance between 2 points and the midpoint between 2 points? We're going to start off here with the distance formula. It says the distance formula determines the distance, of course, between 2 points, or the length of a segment is another way of thinking about it. In order to do this, we have this big old formula here to look at. It says the distance between 2 points, we're going to call those points x1, y1, and x2, y2, is found using this big formula. D, which is distance, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, just for a little color coordination here, what we are doing is we are subtracting the x values in our first parenthesis here with x2 minus x1. And we're going to be subtracting the y values, y2 minus y1. These are both inside parentheses being squared and added together, all underneath the gigantic square root sign. So it looks like a lot, but really you just got to get used to it, and then we're going to be cooking. So example 1 says find the distance between the points 6, 2 and 3, 6. I'm going to go ahead and label this x1, y1, this x2, y2. And let's see what happens here. This is the general setup here. We can always start off by writing out this, and then remember what we want to do. x2 minus x1 in the first parenthesis. So that'll be 3 minus 6. And then in my second parenthesis, I want to do y2 minus y1. 6 minus 2. Now we're going to see a couple different ways of taking it from here, but for this first attempt, let's go ahead and just work it out by hand, see what happens. Now 3 minus 6 is negative 3 squared. 6 minus 2 is 4 squared. Now that's still all underneath a square root sign. Negative 3 squared, negative 3 times negative 3 is 9, positive 9, because a negative times a negative. 4 squared, 4 times 4 is 16, still underneath the square root sign. 9 plus 16 is 25. And the square root of 25, what times itself is equal to 25? That is going to be 5. Now, it could be negative 5, but negative distance does not work out for us. So we're going to take positive 5 as being the distance between those 2 points. Could be 5 inches, 5 meters, we don't know. Example 2, let's run it again. This says find the distance between the points negative 3, 4 and 2, negative 1. Leave answer in simplest radical form. So this, if you see this phrase here, simplest radical form, that means that you gotta solve it by hand, and there's probably gonna be some simplifying involved at the end. But let's set up our general formula here. Remember, you can always write this part out. And let's see what's going on here. So let me label this one more time. x1, y1, x2, y2. So inside first parenthesis is supposed to be x2 minus x1. Ooh, this is where we got to start being careful, because this should be 2 minus negative 3, right? It's x2 minus x1, but minus a negative flips it positive, right? So that's 2 plus 3 in the first parenthesis. And then for our second one, we're going to do y2 minus y1. That's going to be negative 1 minus 4. Okay, so since it's simplest radical form, we are going to need to solve this by hand. 2 plus 3 is 5 squared. Negative 1 minus 4 is negative 5 squared, still underneath our big square root sign. 5 squared is 25. Negative 5 squared, negative 5 times negative 5 is also positive 25. So that's going to be the square root of 50. Now, 50 is not a perfect square, so we don't have a nice answer for that. So that's where the simplest radical form part comes in. So let's simplify this thing. Now here's how I like to simplify things. I like to hunt for pairs when I try to break it down into its factors. So I know that 50 can be broken down into 25 and 2. And 25 gives me a pair of 5s. So if I get a pair of 5s and I have a 2 left over, the simplified form of writing this is 5 square root 2. Remember, the pair comes to the outside, the loner stays on the inside. If you have more than one pair, you multiply those on the outside. If you have more than one loner, you multiply those on the inside. So in this case, simplified form is 5 root 2. All right, then our example 3, once again, find the distance between the points, but this one says round to the nearest tenth. Now, if it says round to the nearest tenth or round to the nearest whole number or anything like that, I have permission to just type the whole formula into your calculator. So it should be pretty easy. Let's just make sure we set it up right, and then you just got to make sure that you're typing it in correctly. So set up our big square root. Remember, you can always write this part in. That part's never going to change. x1, y1, x2, y2. So x2 minus x1, negative 4 minus 5, and then y2 minus y1. That is going to be 10 minus 9. Now, like I said, if they say round to the nearest tenth, then they're just giving you permission to just type that whole thing into your calculator. You don't need to get it in simplest radical form. So I'm just going to type that into my calculator. And hopefully your calculator agrees with mine. Negative 4 minus 5 and 10 minus 9 inside those parentheses. I'm getting 9.05, which would round to be 9.1. Okay, so just keep an eye out for simplest radical form or rounding, because depending on what they say, you might have to do it differently. Okay, let's go to the inside where we've got the midpoint formula. So the midpoint formula determines the halfway point between 2 points. We know what a midpoint is now, well, hopefully. And this is going to be used to calculate where that is using coordinates. So the midpoint between 2 points, x1, y1, and x2, y2 is found using this formula, x1 plus x2. So you are adding the x values and then dividing by 2. And then y1 plus y2 divided by 2. Now, the midpoint finds a point, so you should get an x answer and a y answer. Because your final answer is a coordinate. It's got an x value and a y value. So let's give it a shot. Find the midpoint given those endpoints. Okay, so 1, 4 and 9, 2. Let me set up my midpoint formula here. So x values. x1, y1, x2, y2. Well, you're supposed to do x1 plus x2 divided by 2. So that's going to be 1 plus 9 all over 2. And then y1 plus y2 divided by 2. So, whoa, goodness, sorry. So this is going to be 4 plus 2 divided by 2. So let's practice our mental math here. 1 plus 9 is 10. 10 divided by 2 is 5. And then 4 plus 2 is 6. Divided by 2 is 3. So this is my answer, 5, 3. You don't add those together at the end or multiply them or anything. Remember, the answer to a midpoint formula is a point, so you get an x answer and a y answer. This is not something you can just type all into your calculator at once. You could, if you wanted to, type in all of this and then all of this and get 2 separate answers. That would work. But do not try to type it all in at once. Example 5 says Antonio's home is halfway between the school and the library. Find the coordinates of his home if the school is located at -4, 12, and the library is located at 2, -6. Well, if it's talking about something being halfway, that's our clue that we're using the midpoint formula. Let me label my points. x1, 1, x2, 1, 2. Okay, so let's set it up. Oops, I don't know why I'm writing it out like that. We are supposed to add the x's divided by 2, add the y's divided by 2. Okay, so -4 plus 2, x1 plus x2, and then 12 plus -6, 12 minus 6. Now I'm putting the minus sign because I'm adding a negative. Don't be fooled there. 12 minus 6. And let's practice our mental math, huh? -4 plus 2 is -2. -2 divided by 2 is -1. And then 12 minus 6 is 6. 6 divided by 2 is 3. So my answer is -1, 3. Now, just as a reminder, if you don't trust your mental math, you can always just type this in to get -1, and then type this in your calculator to get 3. You can always do that. Okay, so this one. Point B is the midpoint of segment AC. If A is -2, 4, B is 4, 1, what are the coordinates of C? This one's interesting. Let me draw a little picture here to kind of illustrate what's going on. It says we got segment AC with B being the midpoint. Now check out what points they gave us. They gave us A at -2, 4 and B at 4, 1. Notice that they didn't give us C. We are not trying to find the midpoint. We have the midpoint, right? We have the midpoint. We know where it is. We're trying to find C. We're trying to find the other end to this thing. Now, there's a couple different ways of thinking about this one. I'll show you two different ways to solve these ones. Now, one way is kind of undoing the midpoint formula. Let's just think about what we would do to get the midpoint, right? Normally what we do is we set up the formula, right? We set up that big formula. And let's just think about the x values for a second, right? If we were trying to find the midpoint, we would do x1, which is -2, plus x2, all divided by 2, right? Now, what would that give us? That would give us the x value of the midpoint. But we know what that is, right? That's actually 4. So this actually gives us a little equation, right? -2 plus x2 divided by 2 equals 4. Right, because, of course, like we said, this is the formula, right? x1 plus x2 divided by 2. Now, to get rid of that 2 on the bottom, what we should do is multiply the other side by 2. Right, if we multiply this side by 2, multiply this side by 2, we cancel out the 2's, and we would get -2 plus x2 equals 8. So then what do? Well, we add 2, and we get 10. So that's what x2 is. Now, we can do the same thing for y. So let me show you the same thing for y. So if I do the same thing for y, that would be 4 plus y2 all over 2. Actually, let me write that a little higher. 4 plus y2 all over 2 should be equal to 1, because that's the y value. So we multiply both sides by 2 to get rid of the 2. We get 4 plus y2 is equal to 1 times 2, which is 2. Minus 4. Get y2 is equal to negative 2. So that means that our point is at 10, comma, negative 2. So kind of tricky, right? We gotta kind of undo the midpoint formula. Now, another way of doing this, is going to be to kind of think about it as a pattern. So what do I mean by that? What I mean by is thinking about just how do we get from negative 2 to 4? Right? Because hypothetically, whatever we do to get from negative 2 to 4 should be the same thing that we do to get from 4 to 10, because it's the halfway point. So to get from negative 2 to 4, we'd have to add 6, right? Negative 2 plus 6 gives us 4. Well, what do we do when we do 4 plus 6? We get 10, right? So why don't we try the same thing for the y values? How do we get from 4 to 1? Well, that takes a minus 3 to do that, right? 4 minus 3 is 1. Well, let's do it again. 4 minus 3 gives me negative 2. So if you can kind of visualize that pattern, that's one way of finding the other endpoint. Or if you need to undo the actual formula by doing it algebraically, you can also do that. Two different ways of thinking about it. Okay, what do we have here? Find the midpoint and the distance given the endpoints. Okay. Now, this doesn't say anything about simplest radical form or rounding, so I think that's probably a good sign that we're going to get a nice answer. But let's go ahead and do the distance first, I suppose. So for both of these, this will be x1, y1, x2, y2. Let me set up my distance formula. And let's do x2 minus x1. So that's 3 minus negative 3. Remember, if we subtract a negative, that flips it positive, so 3 plus 3. And then y2 minus y1, negative 4 minus 4. Okay, like I said, it doesn't say anything about something or anything, so I think we're going to get a good answer. Let's just work it out by hand. 3 plus 3 is 6 squared. Negative 4 minus 4 is negative 8 squared. 6 squared is 36. Negative 8 squared is 64. Oh yeah, we're getting a nice answer here. 36 plus 64 is 100. And what's the square root of 100? Well, it is 10. Cool. Now midpoint formula time. So midpoint formula, x1 plus x2, that's negative 3 plus 3. And then y1 plus y2, 4 plus negative 4, or 4 minus 4. Negative 3 plus 3 is 0, divided by 2 is 0. 4 minus 4 is 0, divided by 2 is 0. Our midpoint is 0, 0. Oh, cool. Okay, and example 8. B is the midpoint of AC. A is there, B is there. Find the coordinate C and the length of AC. Round to the nearest tenth. Okay, so we probably need a picture for this one. Here's A. B is the midpoint. Here's C. A is at 2, negative 5. B is at 7, 0. We don't know where C is. So we want to find C, and then we want to find the length of AC. Okay. It does say round to the nearest tenth. So when we have to do the distance formula eventually, we will just use our calculator. So let's find C first. So I'll show you the algebraic way and the pattern again. So I'm going to label C as my x2, y2. And remember, to find the midpoint, we are supposed to do x1 plus x2 all over 2. And we know that that should give me 7. So let me multiply both sides by 2 to get rid of the 2. 2 plus x2 equals 14. Minus 2 gives me x2 to be 12. Okay, so we handled the x's. Now let's handle the y's. So for the y's, oops, not that one. For the y's, I'm going to do -5 plus y2 all over 2 equals 0, because that's the y value of the midpoint. Multiply by 2, get -5 plus y2. 0 times 2 is 0. Add 5 to get rid of that. I get y2 is equal to 5. Okay, so C is at 12.5. Now, what we can do now that we know where x2 and y2 are, is we can do the distance formula with A and C to find the length of AC, right? That was the second part of this problem. So we're supposed to be doing y2 minus y1, so that's 12 minus 2, right? Because this is my x1, y1. 12 minus 2, and then for the other one, we're going to do y2 minus y1. That is 5 minus -5, which minus a negative is a positive. Now, like I said, they said round to the nearest tenth, so I'm just going to type this in my calculator. 12 minus 2 in the first parenthesis, and 5 plus 5 in the other one. And I'm getting 14.1. So that was the distance, and C was at 12.5. Those were the two things we wanted to find. So a good little application of what we saw earlier. Had to do both things on that. Cool. Okay, so it is officially your time to shine. You got 6 problems over there for the your turn. Give them a shot, pause the video, try them out, and then come back when you're ready to check. All right, so hopefully you got them all done. This is what I would have done. I would have done -4 minus 3 in my first one, and then -20 minus 4 on the next one. And I believe if you did that right, you should have gotten exactly 25. That should have been a nice answer one. This next one wanted us to leave it in simplest radical form, so we'll have to simplify. That should have been 2 minus 5 squared plus 3 minus 6 squared. That's -3 squared plus -3 squared. That's 9 plus 9. That's 18. If you break that down, you get 9 and 2, which gives you a pair of 3s. So this should have been 3 square root 2 as your final answer. Number 3 wants us to find the midpoint between those 2 points. So that should have been -2 plus -8, which I should really write as -2 minus 8 over 2. And then 4 plus 6 over 2. -2 minus 8 is -10, divided by 2 is -5. 4 plus 6 is 10, divided by 2 is 5. Now the midpoint, we're going to do 10 plus 4 over 2, -6 plus 6 over 2. 10 plus 4 is 14, divided by 2 is 7. -6 plus 6 is 0, divided by 2 is 0. Number 5 wants us to find the other endpoint here, right? We got A, C with B in the middle. Let me show you the pattern way again. I think this can be pretty fast if you can spot it. To get from -3 to 0, you add 3. So let me add 3 again. 0 plus 3 gives me 3. To get from -3 to 2, you got to add 5. So 2 plus another 5 would give me 7. So 3, 7 would be where C is. Of course, you could do it the other way that we did before. I'm just trying to show you multiple ways on that one. We got one more of those. B is the midpoint of AC. It's time to give us C, though. This is kind of interesting. C is 310. B is 0, 5. So to go backwards here, to go from 3 to 0, actually subtract 3. So subtracting 3 again, 0 minus 3 gives me -3 for A. To go from 10 back to 5, we got to do -5. -5 again. 5 minus 5 brings me back to 0. So A would be at -3, 0 on this one. All right, hopefully you did all right on those. And that wraps it up for this lesson.